أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في مادة الجبر وهو اللي اسمه المحددات. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in algebra. It's titled Determine. Dear student, look at introduction about determine. What is the determinant, dear student? Look at definition. It is value associated with a square matrix. It can be compound from enters of the matrix by specific arithmetic expression. Well, other ways to determine its value exist as well. Determinant also are mathematical objects that are very useful in the analysis and solution of the system of linear equations. Remember, the student, determinants is very important. Why? Because it is mathematics objects that are very useful in the analysis and solution of system of linear equations, where the determinant of degree n consists of n row and n columns. Type of determinant. Number A, determinant of the first degree. What you mean of determinant of the first degree? Look at D1 equals one row and one column, A11. This is called determinant of first degree. Equals the value of determinant A11 is equals A11. For example, determinant of 6 is 6. What you mean? This determinant has one row and one column, is element as 6. Determinant of second degree, D2 has two row and two columns. The first row is A11, A12. Second row A21, A22. What you mean of A21? A21 means the element in the second row first column. A22 means the element in the second row and the second column. By cross multiplication, A11 times A22 minus A12 times A21, this is the value of determinant of the second degree. For example, look at determinant has two row and two column. What is the value? We multiply 3 times 5 minus 4 times 2, answer is 7. Determinant of third degree is very important. D3 as A11, A12, A13, first row, second A21, A22, A23, second row, third row, A31, A32, A33. We have say determinant by using row or column. Has 3 rows and 3 columns. Equals the first A11 by the second determinant. Square determinant is A22. Each element has determinant. A11 has determinant A22, A23, A32, A33. Negative A12 multiply determinant of A21, A23, A31, A33 plus A13 multiply its determinant A21, A22, A31, A32. Remember, the student, each element has coefficient determinant. Determinant A11 is the element, the first row and the first column has determinant. We multiply by its determinant A22, A23, A32, A33. The sign of the cofactor of elements of determinant are positive, negative, are positive, negative, positive, negative, positive, negative, positive, negative, positive. Remember, dear student, the sign of the first row, positive, negative, positive. The sign of the first column, positive, negative, positive. What you note, start from positive, end is positive. 4 corners are positive. Positive, positive, 4 corners, and start from the positive, end is the positive. 2 diagonals are positive. Look at expand determinant. Expand of A11, A21, A31 in the first column, A12, A22, A32, also A13, A23, A33. What you expand? By using determinant, we find expand of the determinant as the form A11 multiply bracket contains A22 minus multiply A33 minus A23 times A32 and so on. Example, look at how to expand by using the factor of the second row. Determine, we have determine of 3 row and 3 columns. Determinant is 3 degrees, third of third degrees, 1, 0, negative 2, negative 2, 4, 3, 3, negative 1, 5. Or what is required? Expand by using the second row. What is the second row? Negative 2, 4, 3. What is the sign of the second? Negative, positive, negative. Remember, look at the solution. Use the second row, negative 2 multiply its determinant. Negative 2 cofactor has determinant 0, negative 2, negative 1, 5. Also 4 has determinant 1, negative 2, 3, 5. Also negative 3 has determinant 1, 0, 3, negative 1. Look at dear student, by using cross multiplication, negative 2 times 0, negative negative 2, answer is, look at dear student, if we multiply negative 2 multiply cross multiplication, we find 2 times 0 inside bracket times 5 minus negative 2 times negative 2 plus 4 multiply bracket contains cross multiplication 1 times 5 minus negative 2 times 3 negative 3 multiply bracket contains cross multiplication 1 times negative 1 negative 3 times 0, answer is negative 4 plus 44 plus 3 equals 43. Remember that, dear student, solve the equation determinant of the 30th degree x 2x plus 1 0 6 3x. How to solve equal 0? We find the value of the first determinant by using element of the first row. Look at x multiply bracket contains 6x minus 6 multiply x plus 1 minus 2x plus 1. The second element multiply its determinant negative 3 times negative 3x minus 0 plus 0 multiply bracket negative 6 negative 0 equals 0. We find the value of equation is negative 6x plus 6x power 2 plus 3x equals 0. By using like terms, we find 6x power 2 minus 3x equals 0. By using highest common factor, what is the highest common factor? Dear student, 3x. Then we multiply 3x multiplied by bracket contains 2x minus 1 equals 0. In this example, x equals 0. Why? Because 3x equals 0. Then x equals 0. Also 2x negative 1 equals 0. What is the value of 2x equals 1? Then x equals 1 over 2. Then the solution z is 0 and 1 over 2. If omega is one of cubic roots of 1 and I equal square root negative 1, prove that this equation, look at determinant, has 3 row 1 I omega, omega I 9 minus omega 0, omega square I negative omega square omega equals 0. Then D equals, by using expand 1 multiply negative omega 0 negative omega square omega negative I multiply determinant omega I 0 omega square I omega plus omega square times its determinant omega I negative omega omega square I negative omega square. Then we reduce that. The answer is negative omega square minus 0 inside bracket negative I multiply bracket contains omega square omega minus 0 plus omega square multiply bracket negative omega power 3 times I plus omega 3 times I. Answer is negative omega square negative omega square I plus omega square times 0. Answer is negative omega square plus omega square, then answer is equal 0. Now we are translate to properties of determinant. Dear student, in determinant, this is very important lesson. We have two types or three types of determinant. Determinant consists of one element is called determinant of the first degree. Second degree is square determinant, has 2 rows and 2 columns. But in most problems we use determinant of third degree. Third degree has 3 rows and 3 columns. Remember, dear student, omega square equals omega square, omega plus omega square plus omega power omega plus omega square plus 1 equals what? Equals 0. Then remember, what is the omega? Is 1 root of the unit 1. What is the I? I is square root negative 1. Remember, in complex number, I is equal square root negative 1, but I square equals negative 1 by I power 3 equal negative I power 4 equals what? I power 4 equals 1. But omega plus omega square plus 1 equals 0. Omega power 3 equals 1. Omega power 3 is equals omega power 6 equal omega power 9 and multiples of 3. Dear student, now we are translate two properties of determinant. There's very important properties in determinant. The first properties in determinant, the value of determinant doesn't change if its row replaced by its column of the same order and vice versa. Remember, dear student, the value of determinant does not change if its row replaced by its column of the same order and vice versa. Example, look at determinant. The first determinant 2, 5, negative 1, 0, 3, 4, 0, negative 1, 1 equals 2, 5, negative 1. The first row is the first what? Column. 2, 5, negative 1, the first row must be equals 2, 5, negative 1, the first column. Not a change. The value number 2 of the determinant is unchanged. By expand, it is term of the element of any its row or column. The value of the determinant is unchanged by expand it in terms of elements of any of its row or columns. Look at example. We have determinant have 3 row and 3 columns. 3, negative 5, 4, 9, 1, 2, negative 4, 4, 0, 0. Then by using first row, determines by expand 3 multiply 0 minus 0 plus 5 times bracket 0 minus 16 plus 9 multiply 0 minus 8. Answer is 80 minus 72 equals 8. But using third column, look at 9 times bracket contains 0 minus 8 plus 4 multiply bracket 0 minus 20 plus 0 multiply 6 plus 5. Also answer is equals 72, negative 72 plus 8 equals 8. Number 3, if the two row or columns are of determinant exchange, what you deduce? Their position exchange, the value of resultant determinant equal negative the value of the original one. Remember this one, if exchange the first row and second row, or the first column, the second column, the resultant of the first equal negative the value of the original one. Example, if we have determined 2, 5, negative 1, 1, 3, 0, 7, negative 2, 0 equals negative, we exchange the first, look at determinant, the first determinant 1, 2, 5, negative 1, the first row. In right hand side is the second row, 2, 5, negative 1. The value is negative the result. Change R1 and R2. Number 4, the value of determinant equals 0 if all determinant of each row or columns are equal to 0. Remember, dear student, the value of determinant must be equal 0 if all determinant of all elements of one of each row or columns are equals 0. Example, look at the determinant, the third row equals 0. The first row 8, 2, negative 1. Second row 5, 4, 3. But third row 0, 0, 0. In this example, the result is must be equal 0. Why? Because the third row all elements are equal 0. Then the result of determinant, the value is must be equal 0. Because R3, element of R3, all elements of R3 equals 0. Number 5, if the corresponding elements in the two row or columns of any determinant are equals, what's the result? The value of determinant must be equal 0. Remember, dear student, if we have determined the two rows of the first or second row are equals, all elements are same, then the determinant must be equal 0. Look at example. This example, we have determined D335 first row, 114, 226 third row equals 0. First, second column. First column 312, second column 312. Then all elements in the first and the second column are same. What is the result? We deduce that the determinant or the resultant or the value of determinant must be equal 0. Because C1 equals C2 means column 1, all elements of the column 1 equals all elements in column 2. Number 6, if K is common factor of elements of any of the row or columns of the determinant, then K is a factor of this determinant. Look at determinant 2, negative 5, 3, 4, 15, 1, 3, 10, 2. What did you use? Or what you notice? Look at the second column. Negative 5, 15, and 10 has common factor 5. The 5 common factor is factor of determinant. Equal 5 multiply the new determinant 2, negative 1, 3, 4, 3, 1 3, 2, 2. Why? Because we take 5 common factor from the second column. Second column, negative 5, 15, 10 becomes negative 1, 3, 2. Why? Because divided by 5 common factor, then the 5 is factor of determinant. We deduce that factor of elements of each row or each column is the factor of determinant. Taking 5 as common factor from the second column. Example. Prove that, dear student, we have determined the first row BCA square, second row CAB B square, third row ABC C square equals determinant 1 A square A power 3, 1 B square B power 3, 1 C square C power 3. Solution. By multiplying the first row by A, second row by B, third row by C, and determine of left hand side and dividing by ABC. Remember, we multiply the first row by A, second row by B, third row by C, after that divided by A, B, and C. What you deduce? Left hand side becomes 1 over ABC, or divided by ABC, multiply new determinant. If we multiply the first row by A, second row by B, third row by C, determinant as ABC A square A power 3 first row, ABC B square B power 3 second row, ABC C square C power 3 in third row. Look at what is the common factor of the first column of A. What is the common factor of the first row? We find a common factor. In second row, B is factor. Third row, C also factor. And look at ABC. ABC. In the first column, factor ABC. ABC, A11, ABC, A21, ABC, A31. Then we use or we taking ABC highest common factor from the first column. What you deduce? ABC over ABC multiply determinant 1, 1, 1 in the first column, A square, B square, C square second column, A3, B3, C3 in the third. Then we deduce right hand side 1 determinant 1, 1, 1 first column, A square, B square, C square second column, A3, B3, C3 in third column. Then left hand side equal right hand side. Remember, dear student, if we multiply the first row by A, the second row by B, the third row by C, after that divided determinant by ABC, the answer left hand side must be equal right hand side. Another example. Without expand, prove that, dear student, determinant 0KL, negative K0M, negative L, negative M, 0 equals 0. By using properties of expand, how to prove that, dear student, this determinant equals 0. Dear student, how to prove that determinant equals 0? We prove that determinant equals 0 if the first row or second row or third row must be all elements equal 0. Or the determinant equals 0 if all elements of the first or second or third column or row equals 0. And in this case, we have two methods to prove that the expand equals 0. The first method, we must make all elements in two rows or two columns equal 0. The second method, we can make all elements in any row or any column must be equal 0. Look at where KLM are any value. Solution. By taking -1 as common factor, then from R1, R2, R3, then determinant is -1 common factor. The first row equals 0, negative K, negative L. Second row K0, negative M. Third row LM0. By taking -1 common factor and change row or column by change, look at the determinant must be equals -1 multiply determinant 0 KL negative K0M negative L negative M0. What you deduce? We deduce that D, the right hand side is determinant of D. Then D equals negative D. What you deduce? D negative 2D, then 2D equals what? 0. In this case, D equal negative D. By using like terms, we find 2D equals 0. Then we deduce that D equals 0 equals right hand side. Number 7. In properties number 7, very important property. In determine, if all elements of any row or column are written as the sum of two elements, remember, dear student, if all elements of any row or columns are written as the sum of two elements, then the value of determinant can be written as the sum of the two determinants. Dear student, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.